Hi, good day to you, and welcome to my channel where I tutor you in science for free. The topic in this video will be measurements. And wow, what a journey it has been. This is the third subject of this channel. The first subject being biology, then chemistry. Now we are coming on to the physics segment. As you can see, was in alphabetical order. Thanks to all the subscribers and all the viewers for helping to keep this channel alive. And without further ado, let's begin. Firstly, with a brief description of what these three sciences are all about. Physics is the study of the non-living phenomenon in the world. Biology is studying the living entities in the world. And the chemistry portion is studying the building blocks, the atoms that spans, of course, both the living and non-living. And that is why the nickname of chemistry is always called the central science. And the biggest tip that I always tell my students is to be able to recall all the formulas. If you are having the Marshall Cavendish textbook, the formula page is conveniently at the back. Always train yourself to be able to recall all of them, and when you are doing questions, you are to be able to do this, what I call the extraction, throw formula and sub in the values and execute some correct mathematics. And by doing this set of actions correctly, it's really pretty difficult to score anything below a B for physics, because there's a lot of the same execution, the same movement. Okay, so let's begin with the lesson proper for chapter 1 in measurements. So of course, the non-living phenomenon in the world spans a lot of things, spreads across a lot of events like all this, and to quantify them we use physical quantities like shown in this table, and their common SI units are shown. SI units stands for this. The SI units is a common way to communicate units and to be able to describe things and put ideas across from person to person of different nationalities seamlessly and easily. So it's a common agreed upon standard unit. So all of this will be repeated a lot. You'll get very comfortable with all of this, except probably the word candela. Mole is small in chemistry, and these are what we call base quantity, whereby there is no particular formula to get to this unit. This unit is just there as it is, using a certain tool, which we'll be talking about later, to obtain the measurement to get this information. So that is base quantity. For derived quantities, there is a certain formula to put things together using base quantities. So things like these, as you can see, they are made up of a couple of base quantities. You put them together, length multiplied by width, you get an area, and so on and so forth. So these are actually already very common derived physical quantities that you have actually already seen since primary school. And of course, units being units, they are of a standard amount, and not all items in the world comes in that standard amount. Like stones, they don't all come in 1 meter size. They are of various sizes, so we need to have prefixes to describe them more accurately. And so prefix, the word prefix is the word that is fixed before the actual word. That's why it's called prefix. If the words comes after that, like organic chemistry, methane, ethane, propane, that will be more of a suffix. The word is fixed at the end. This will be the prefix words that are mini words that are fixed in front of the original word. So certain things are very common to you already, things like centimeter, kilometer, and these prefixes are used to describe a much larger amount or a much smaller amount. And if you want, you can commit them to memory, I guess, by doing lots of questions, and things get into the mind a little bit easier. And next we go on to standard form. Standard form, there is a lot of very complicated definition, but what I would like to just share is the easier way to think about it is just standard form is a way to express the very large or very small amounts. So it's always something point something times 10 to the power of something. So you got to fill up these boxes, and it should not be a 0 in the front, or it should not be a double digit in the front. Then that is all you got to remember. As long as the 3 boxes in front are filled up, you should be correct. And in school level, it should be 3 significant figures, so just follow this format, you should be fine. And of course, if you're moving the decimal points, remember to move the powers also. If you're moving a certain value in decimal point in front, you're decreasing it, the power should be increased, and vice versa. So measurement of length, very common. We use these items and just have to take note of parallax error. And for every instrument, it is only meant to measure a certain physical quantity through a certain range. So for example, the ruler in your pencil box will most likely be able to measure length from 1 millimeter to 15 centimeters. That is the range, and the accuracy of the smallest unit will probably be 1 millimeter. That is the design and the characteristic of that tool. So every tool comes with their own accuracy and range. Meter rule can measure up to 1 meter. So measuring smaller lengths, you use the vernier calipers. You can measure internal diameter, external diameter, depth as well, using the tail or the jaws accordingly. Sometimes a certain odd shaped item whereby you want to determine the length, you use a external caliper. So you just take the caliper and bite it along the item, and you place that caliper on the ruler. So using the vernier calipers, you have to look at the small scale where the 0 is pointing at. So over here, if it is like 3.1, so you can see that it's more than 3.1. It's 3.1 something. So what's that last something? You gotta see what line matches up. So over here, the fourth line matches up. So it's 3.14 centimeters. That will be the way to read a vernier caliper, and the accuracy will be 0.01 cm, and positive zero error will look like this. The 0 is already in front of the 0, and so the line that matches up is the third one. When you take your reading, just remember to minus the zero error off, and negative zero error will be when the 0 is already pointing behind the 0 on the main scale, and you have to count the divisions from the back. And so when you do your measurements, you have to remember to add it back in. Okay, what happens if it is a even smaller item? Say for example, the thickness of a coin. The accuracy will be 0.01 millimeter. So you can see that the vernier caliper has certain accuracy. The micrometer has an even smaller accuracy. The calipers is 0.01 cm. The micrometer screw gauge will be 0.01 mm. So that eases up a lot of brain power used to memorize things, I guess. And so here are a list of the different parts of the micrometers. You don't really have to go and commit them to memory. This is the way to read the micrometer screw gauge. The thimble spins downwards. Okay, so this in this example, it has passed the 5th, 6th, 7th, 8th, 8.5 millimeter mark. So it's 8.5 something. So over here, it is an addition of 40 units. You can see over there at the thimble scale. So you have to add it in. 8.5 plus 0.4, you'll get 8.9. And if it is in a closed position and the 0 is already pointing off the datum line, the main scale, means it has a positive zero error, so you have to remember to minus it off. Similarly, if it is pointing at the back, you have to remember to add it back in. So, and next, measurement of time. There's pendulum, there's stopwatches, clocks, and usually in terms of measuring time, there's always this error called the human error, the human reaction time. And the usual tip that science likes to iterate to students is to take multiple readings and just average them out. And one of the more, if you have been following my videos, one of the more commercial way of doing things or scientific way of doing things is to use video. So you can count from the frame to the other frame. And looking at the pendulum, usually we are concerned about one oscillation. So I usually tell students that there and back again is one oscillation. There and back is one oscillation, one period. And the time taken for one period is used to mark a certain amount of time, and the amount of time is allowed to swing will multiply that amount of time. And yes, of course, because we are in physics lessons now, you have to note that prolonged swinging of this pendulum bob will slowly start to decrease its angle because of the air resistance that it experiences every swing. Although negligible, but over a large period of time, many repetitions of swinging, all this air resistance starts to add up and slow down the pendulum. And the swing angle gets smaller and the oscillation, the period, gets shorter. And that is all for today. Hope you enjoyed this video. Do give it a like and subscribe, and share it with somebody who needs to see this. And I will catch you in the next video. Bye!